Hi, everyone. Thanks for joining. Yeah, during the actual demo session, we faced issues in the Zoom connectivity and the recording was not proper. It got interrupted. So sorry about that. So that's why I'm doing one more recording. Okay. So my name is Ranjit Naik, and I will be a trainer for the Terraform, and this is a demo session. And just to have a quick intro of myself, I am working on the infra side, mainly on the primarily on the Unix Linux admin side since last 15 plus years, and into automation and config management tools like Puppet and Ansible, okay, and scripting using Perl, Python, and all, and on Terraform as well. Okay, so I'm primarily working on the Azure and AWS cloud. So like I enjoy to work with the Terraform tool, okay, and it's a very nice tool to learn. So, and from the teaching point, like I enjoy teaching a group of students and all. Okay. So that's a quick short intro, and let's see what is Terraform. We'll try to understand that, and we'll see how what are the topics we are going to cover in it. Okay. So during learning of any particular tool, any new tool, there will be some prerequisites. Okay, so the prerequisites of the Terraform is basic knowledge of some cloud provider. Okay, maybe Azure or AWS or GCP. Anything information like any knowledge on any of these cloud or working will be good. Okay, because we won't be deeply going into the cloud technologies. So we assume that at least the student knows these things. Okay, and we don't want to learn deeply into the cloud. We will, even if the person is aware of from the high, from like a top level, he knows all the things, how the VM, what is a VNet, what is VPC, what is internet gateway, subnets, and all those things. That's sufficient. That's fine. Okay, and this is Terraform is not kind of a it is not a kind of a general purpose language like how Perl, Python, or C, Java. It is not like that. Okay, it is mainly a declarative language and used primarily for infrastructure provisioning. Okay, so I just told declarative programming language. So nowadays a lot of programming is coming. For example, your Chef, ARM template, through the ARM, Ansible, or this Puppet and all. So all those are declarative programming where there will be argument. Okay, your key and the value will be there. It's like that. You have to define the end state. So you don't have to tell each step by step how the task has to be done. You have to just declare that this should be your end goal, how the infrastructure should look like. So you're defining. So that is called declarative programming. So this is one of, so this is a declarative programming language actually. So that's why we don't see a lot of core functionality like how the usual functional programming languages are. So those things will be missing. A lot of things will be missing. Okay. But as I told, this, like whoever wants to learn, just as a if the candidate is thinking or the student is thinking that this is a general purpose language, let me learn this programming. So it won't be of much use for them. So this language will be primarily useful for the DevOps persons or the whoever are in the infrastructure side or the cloud administration or the cloud SME management, like whoever is engaged in the cloud, it is primarily for them. Okay, you can even manage the on-premises network as well. You can manage a lot of things within on-premises, VMware, all those, but it is not extensively used for that. Okay, there are customers who use for the on-premises provisioning as well, but it is currently it is primarily on the cloud side. Okay, So we will see now, like, what is the use case, why, what problems it solves and all, and we'll see that. Okay. And furthermore, if you are already aware of some declarative language like Puppet, ARM, Ansible, it is beneficial. It is not mandatory. Okay, just I have written like that. Okay. So let's see why we want to learn Terraform. So you all have come here, right, to see the demo session. So there should be some objective for you, like why you want to learn Terraform. So I see the candidates or the students coming from particular groups, like if they are already working in the cloud, maybe in the Azure cloud or AWS or GCP. So those students will come to expand their knowledge, okay, or do something in the provisioning side. So that is one group of students. So second group of students, they are into the DevOps and they are planning to use Terraform or maybe using Terraform. So they want to explore more in the Terraform and see more capabilities, what it can all do. So that is one category of students. Okay. And one more category of that from the DevOps team, students come where they are with the developers, like they facilitate the developer group for provisioning their infrastructure. Okay, it could be infrastructure, it could be IaaS or PaaS. Okay, so these are kind of students who are coming to it, and some of the students who have not even started working on the Terraform tool itself, so they also come. Okay, just to get the initial hands-on to it, so that it helps them to learn quickly. Okay, so if you are exploring on your own, it may take maybe 2 to 3 months, but when you are joining this group and all, it will be much quicker for you. Okay, to quickly learn the things, so you are saving the time. So these are kind of the groups of students who come for the Terraform. So this slide I'm just showing what are this is the Google trend of the Terraform search. Okay, and we see that gradually this trend is increasing over the time. Okay, in recent years it is quite increasing and it is in growing trend. Similarly, the company, the vendor actually, the vendor name is HashiCorp. Okay, so the HashiCorp company has released the tool Terraform. They have many other tools as well, very famous tools like Packer, you might have heard, and HashiCorp Vault is there. So this is one of the tool, Terraform, which is primarily used for provisioning. Okay, so we see the company valuation is also increasing in the trend. Similarly, in the LinkedIn search also, we see the Terraform quite a good amount of openings are there. Okay, it may not be only dedicated for Terraform, maybe in the DevOps area. You're ticking one of the main box in the DevOps side if there are students coming from the DevOps. Okay, so that overall, this is the overall view of Terraform. So this gives some motivation to learn this tool. And we'll see what all topics we are going to learn. Okay, so first our section will be the intro sections, where we will see high level introduction of the tool, and this section is kind of a like 10,000 foot view of the entire estate. Okay, we will see everything from very top view, and then in this section we will see the connectivity from your machine, your laptop, to your cloud premises, to the cloud, maybe it is Azure or AWS, whichever you are connecting to. Okay, our examples will be from AWS and Azure. Okay, so I would say 50-50 or 60-40, like that, Azure or AWS, depending on the students and all, we will go with that. Okay, but our primary focus will be always learning Terraform. Okay, not learning the cloud. So nothing to be worried, even if we are AWS centric and there are some examples of Azure, it's not like that it's waste of time. Okay, so because our primary focus is to learn the syntax and all the blocks of Terraform. So in this section, in the intro section, we are going to learn very high level Terraform benefits and all those, and then we will go with the installation of all the tools. Okay, so we would need initially the Visual Studio Code. We'll install the actual extensions whichever are needed and all the tools related to the cloud, and then we will discuss the high level blocks because Terraform is primarily a block oriented language. Okay, so everything you declare will be within a specific block. So we will see that what are the types of block and all those in this section. And the subsequent sections, we will go deeper further into each of the block. Okay, so the second section, we are going to see one of the primary block, the Terraform and provider blocks. And then we will go to the section 3, which is quite big, where here we are going to see all the variables, and we will see meta arguments. Okay, and there are a couple of types of variables in it, ranging from your normal variables where you can give string numbers, boolean like that, and then going for collections, list, map. Okay, and then the structural as well. So it is objects and all those. So we will see all those, and we'll identify which use case, which variables will be used. Okay, maybe you want to create a AWS server, okay, with some security group and all those. So you have to give all that information, the port numbers, which all will be allowed and all. So which variable will be better? We will see all those use cases. Okay, maybe you are going to create some S3 storage and you want to upload some files. So where to give, what kind of variables will be there? We'll see that. In Azure, let's say you are creating some NSG, and in those you are creating multiple rules. Okay, so how the variables, which variables will be better to it? Is a list variable or object or map? Okay, or list of maps? All those things we will see here. Okay, and in this chapter we are going to deep dive on the resources as well. We will start creating the resources in this, and further we will see the Terraform state file. So it is quite an important concept within Terraform, the state file management. Okay, and in this chapter we are going to create the example of resources. Yeah, here's the example of resources. We'll take a couple from Azure and few from AWS as well. Okay, and if there is an interest from the students, we will definitely go for Google as well, the GCP cloud as well. Okay, we'll take some examples from there, and the examples will range, will be extensive, like it's kind of a project kind of thing will be there. So it may not finish in one session. So I will show just how the examples will be. Okay, so this section we will spend a lot of time, and once these are done, whatever code base we have generated in this, we will now go to the module section, where we will reuse this code and develop it into modules. Okay, and upload it into Terraform public repository, so that anyone from anywhere, like in the whole world, they can use it to consume. Okay, so the modules are used mainly for the abstraction. Whatever complicated code you have written here, you are abstracting everything and giving a very simplistic view to the end user. Okay, maybe 200 plus lines of code, you are reducing it to just 3 or 4 lines. That's it for the end user to give. So the end user don't have to know Terraform at all. So then still they can create the resources. Okay, with the very minimum knowledge they can do that. So this is one of the use case where the DevOps engineer come into picture in your organizations or in your projects. If you see, a lot of time you will spend a lot of time in creating modules, okay, which you will further distribute to the developers. Okay, so the developer may be a Node.js developer or a .NET developer. They don't have to know Terraform, but still they can provision their infrastructure with whatever module you have given to them. Okay, by using maybe 4 or 5 lines. Just saying, giving a rough example like that. Okay. So this will be quite interesting topic 4, and then we will go to the Terraform state. We'll see what is the purpose of state and all, and what is the benefits and all those. Like there are a lot of commands in that state management commands we will do, and here we will configure the remote state as well. We will use Azure storage container as well as AWS S3 also we will use for the backend state file, okay, so that multiple persons can work using the same state file. Okay, backend remote state file. So then we will go to the Terraform expressions and functions. As I said earlier, this is not a full-fledged functional programming. So there are limitations in the function. So we cannot create our own functions, but yes, whatever functions are provided by HashiCorp, by the Terraform themselves. So we have to use those. So we'll discuss all those functions in it. And then we'll see the Terraform logging and debugging, where in some scenario, maybe your code is not running and all. Okay, means not your code, like if you're getting some errors while connecting to the Azure, or maybe some VM is not getting created, you're not able to identify, your code all looks fine, but still there are issues. So all those kind of debugging, troubleshooting, we can see what all logging options are there. Okay, and then we will see the Terraform cloud. So currently, whatever we in earlier we have learned, so this is the, you are working on the code yourself. Okay, but in the Terraform cloud, it will be more on a collaboration. Okay, so you are working within a team and multiple people are working in a same project. Okay, so then you configure the cloud, and in this, whatever earlier modules we created, we will upload that to the Terraform cloud as well. Okay, in a private repository. So this is also quite nice topic. And then in this we will see the quick introduction to Git as well, because there is a integration with Git with the Terraform cloud, and you can trigger your provisioning just from the Git, just from the code commit itself. Okay, so you will write the code and you will commit it to your Git repository, and it will trigger the build itself. Okay, it will trigger the provisioning part of it. So you don't even have to log into the cloud portal or the or anywhere. It will be just built. Okay, just with your code commit. So we'll see all those and how we can trigger the provisioning in the Terraform cloud. And once this is done, we will see further. We'll check the Azure DevOps as well. So we are not going to do complete Azure DevOps. It's quite a vast tool, but we will see only the interested topics, mainly the repository sides and the pipeline creation and all. So we'll create a pipeline with Terraform, and we'll trigger it, okay, from end to end. So these are all the topics which we are going to learn, and our topics will be focused around the certification as well. So it covers the certification aspect as well. There is a certification called HashiCorp Certified Terraform Associate. Okay, I'm already certified. I given this exam in December, so it's quite a good exam here. And so what I have done is the topics, whatever we learn. Okay, so the exam topics are a subset of whatever we are going to learn. Okay, so to be assured, whatever topics are there in the exam, they are well covered in our learning point of view. Okay, so for example, these all will come in our section 1, the introduction, and CLI also is covered in that. All the commands we will see from the day to day. Whenever we are going to do, we will go through all the commands. Modules chapters we are doing in much deeper, whatever is there in the exam. Okay, exam, it's very high level they've given, but actually we are going to do much further. So we'll create our own modules. We will upload them to the Terraform public registry. Okay, which is not there in this exam course, but it is needed from practical point of view. So I've added that. And then Terraform workflow, yeah, we'll go through that. State management, we are going a complete section in that. And yeah, these all will come in our section 3. And Terraform Cloud and Enterprise. So Terraform Enterprise is a licensed version, which unfortunately we cannot do practicals on it. But Terraform Cloud there is a free option is there. Okay, so we'll do hands-on on the Terraform Cloud, but we'll go through the theory part of the Terraform Enterprise. Okay. But all these are like extra features are there, but the core of the Terraform, the programming and all remains same. Okay, so in our day-to-day practice, we are going to use the Terraform open source. Okay, so these all are the topics. So whoever candidate are interested for exam, they can go for that after the course is over. So coming to the high level of Terraform. So Terraform is a infrastructure as core tool. Okay. So as I said, infrastructure. So currently the definition of infrastructure is quite vast. Okay. Than earlier infrastructure means maybe server, rack, or CPU, RAM, all those things we used to define. But now infrastructure is quite went to a high level as well. Okay, so infrastructure is including all those things, the VM and your NIC card, your NIC everything, IP address and all those. But now it is taken much more. Now it is the SQL server is also part of your infrastructure. Maybe a container is there. Maybe a Kubernetes cluster is also part of that. Okay, all these definitions. Okay, and then this Terraform is used to create your provision and manage your infrastructure. Okay, so manage means to manage the life cycle. So let's say you provisioned a VM. Okay, and down the line after 1 week or something, you want to change you want to add one more disk or something like that. Yes, you can do it through the same Terraform only. Okay, and once your all project is over, you can decommission the VM from Terraform only. You can destroy it completely. Okay, you don't have to track in your inventory sheets and all which VM, how many disks and all those. So these all are there in your code itself. Okay. So all these things that Terraform can do, and Terraform is a declarative language. So that's why to learn it is quite easy as compared to other languages. Okay. And Terraform was released in July 2014 by HashiCorp company. It was the initial version 0.1.0. And we see that there are multiple iterations. Okay, so the tool is evolving and it is very dynamic. It's a very they have a very big group of developers and senior people on those. So we see the product is evolving very much. Okay, so currently it is in the 1.0.x version. It is there. So the versioning is like the major, minor, and the patch fix in the patch version. It is like that. So it's good that it's very dynamic, it's evolving. So people are in a lot of people are using it globally. So and the Terraform uses in backend, it uses the HCL, the HashiCorp configuration language. Okay, so that is the actual language which is used by Terraform. And you can also use JSON, but the JSON is not very human friendly when you code. Okay, so we will use the HCL in our coding. Okay, and recently there was a multi-cloud survey done. Okay, so here we see that the HashiCorp set of tools are quite in heavy demand. Okay, so whatever vendors are there currently, whatever organizations, if they're with one cloud, so they may want to go to other cloud, and also what is preventing them is again to all the whatever established process is there. So they have to adjust in the new cloud. Okay, for that. So that is quite a very big investment for that. So for example, there is a customer who is using Azure. Now they want to go to AWS. Okay, so it's not only adopting the cloud is a challenge. Okay, adopting, you have to establish all the process, whatever current process are there for the Azure, you have to ensure all those processes are there. The automated provisioning process, whichever is there in Azure, you have to ensure again it is there for AWS. So AWS, you have to learn the your cloud formation and all. Okay, for automation. And again, let's say down the line you are going for GCP, and also you have to do the I think the deployment manager is there in the Google. So there are different set of tools given by each vendor. So it's not possible for each team to again learn each and every team and become master and create process and automation and all. So it takes time. Okay, establishing all those processes takes time. So so using Terraform, what it does, it acts like a intermediate. Okay, so you have to just know Terraform, then you can provision Azure and all. You can manage and provision Azure cloud resources. You can use the same skills to create and manage the AWS or the GCP, okay, or even the other clouds as well. For example, Oracle or the IBM cloud, DigitalOcean, many vendors are there. Okay. So what it solves actually, so the currently there are many pain points. So for time being, just assume that Terraform is not there. So what are your options? Okay, and what are the pain points? So let's say you have to build 10 VMs for a development project and all. Okay, you took a couple of days and all to build all the infrastructure, and over the down the line a lot of changes happened. The disk changed somewhere, the CPU size and all those things changed. Now you want to hand it over to the staging or the operations team, okay, whoever they will build the new production environment. Okay, so again you have to give all those information, you have to hunt all those information, create in some Excel sheet and all those, or share some snippet of screen share and all, you have to give that. So that is one of the pain point. Okay, replicating the environment is a pain. Again, slowness is one of the pain point in that. And managing the life cycle across a period of time is one of the bigger pain. Okay, for example, your development is going through a couple of weeks or maybe months. Okay, so during those tenure of time, a lot of changes will happen. So not all the time everything is documented. You know that many times some things may be skipped and all. So that's why recording all those events are are, are, are a very big, like high effort intensive. Okay, so Terraform solves all these challenges. And many times what will happen, your document says something, let's say a disk size is 100 GB, but in actual the disk size may be 200 GB or something like that, because to solve some problem in backend some team has already increased it. Okay, so your document won't reflect those changes. So these are all the pain points. So this is all solved by the Terraform. Okay, so here in this slide we'll just see infrastructure as code. Okay, so what through that use of the Terraform, what we can do is we can whatever our infrastructure is there, we can codify it. Okay, maybe you have got 10 VMs, okay, some load balancer, some subnets, some VNets, and all those things, the external disks. Okay, maybe some zone recorder, some DNS zone records, all those things, so we can put it in a file only. Okay, so that's why it is coming as your infrastructure, everything you are putting it in a code, in a file. So now what is the benefit is that you can do the version control of those file. Okay, you can upload into the VCS, you can use Git or whatever, Dropbox, whichever you want, you can use that and maintain your version control over it. Okay. And using infrastructure as code, the thing, whatever deviations are there, it will be recorded. So let's say in the backend some deviations happened. Okay, maybe some to solve some problem overnight, some team has expanded the disk and all. Okay, so when you are tracking through your code, infrastructure as code, when you do the refresh and all, it will come to know that okay, there in the backend the changes has happened, and it will accept those changes. Okay, so we'll see all those in practical. And there are substantial benefits of IAC. One is the one thing is, so these are all the pain points, and now these are all solved by the IAC. One is the consistency, repeatability, and how quickly you are building your infrastructure. Okay, so when you take less time, so that lowers the cost. Okay, so the resource, earlier it used to spend 2 weeks maybe for the end-to-end 20 or 30 servers. Now we spend maybe 1 or 2 days. Okay, I can't say I cannot say it will be in minutes or like that. In ideal, like it still takes a production ready environment, still takes a day or couple of days. Okay, so that is the realistic value. Maybe you can create a VM and all just with a couple of seconds and all, that's all fine. But when we say a production ready environment, it includes all hardening and everything and all, it takes time for those. Okay, but still substantial less time than doing it manually. Okay, and it will increase all your quality, and then you can share your ISC code as well, okay, with the other teams. And so Terraform is HashiCorp's infrastructure as tool, and it it lets you define the resources, like we are defining the target, like how our target will be. We will defining that our desired state. So this given a small code snippet where how it will, our target infrastructure should look like. So for in this example, our resource group in Azure, the name is demo RG and location is West Europe. So we want, so this is fixing this, like this is our target state. So once we execute that, it will create the resource group in West Europe. Okay. Similarly, for this one, it is creating a storage account. So you can see just a high level, like how the how the block looks like, and it is all like the argument. Okay, your key name and the value, whatever is there. So it's quite easy, isn't it? It's not look like very. It doesn't look very complicated as such. Okay. So there could be some nested blocks will be there. So for example, this is one of the block of AWS instance. There is one more block we can see inside the tags. Okay. So this is a very high level, just is there. So it will be mainly a block level. Okay. And Terraform, whatever resources we are creating and all, it will be tracked by Terraform. Okay. So any deviation happened when you are doing the next run of the Terraform, it will probe the backend cloud and all, and it will let you know. It will, like whatever changes it can see. Okay. And it won't apply the changes immediately. It will prompt you first. Okay, that these are the plan, whatever it is going to do, it will tell before that. And this is one of the information I got from a blog for cost comparison of the cloud. Okay, so here if you see right now, the AWS, Azure, and the Google, these are the primary three cloud vendors are there. There are many others at this point, but these three are primary. Okay, and the cost varies actually. Okay, and the cost is again not fixed. This cost will change. So it is like your share market, how it changes and all. So when the other one of the cloud vendor is reducing the cost and also the customers will tend to go towards it. It's like your own, how utility vendors are there, like okay, your electricity, your water, or anything like that. So if you see other supplier is giving something with less price, you will tend to go there. Okay. So this is one of the driving factor. The cost is one of the primary driving factor. Okay, where the customer decides to go for which cloud. Okay, because they know at the back end, the resources, the hardware, the infrastructure is quite robust and all. Okay, so cost is one of the top deciding factor. Okay. So now here Terraform comes into picture. Okay. So in this diagram, we are just saying, okay, for example, I am a customer and I have Azure currently. Okay, so my established, I'm doing all the provisioning using the ARM templates, or I have some PowerShell, I'm using Azure CLI and all. Okay, so a lot of things are there. It's established. The teams are aware of all this. Now, if I have to introduce AWS, I have to go for CloudFormation, or the AWS CloudFormation, or the AWS CLI, all those. Okay, I have to learn again. The team has to be trained in that. And again, if some customer is going for GCP, they have to trained on the deployment manager from Google. Okay, so all these are complex things are there in between. Many tools are there. So what Terraform does, so it will transform your current this infrastructure to this. Okay, so underneath the cloud vendors will be there, and the Terraform will act like your virtual layer. Okay, and your provisioning process will be coordinating with only Terraform, and then Terraform will coordinate with the clouds, with the individual cloud. Okay, so your automation process, your way of declaring the resources and all will be similar. Okay, irrespective of it is Azure or the AWS or GCP. So this brings it removes a lot of complexities, and it gives a facility, like it gives at least it gives some additional advantage for a customer to move to one cloud or to migrate to the other cloud. Okay, it gives the flexibility. So in the coming sections, what we are going to do, actually we'll do the installation and all those, and there are quite around 150 odd slides will be there in it. And as I said, let me see some of the quite And each of the slide, whatever topic we are doing, it will be given like hands-on for each topic itself. So yeah, as I said, in section 3 we are going to do a bit of complicated resources. Okay, in each of the topic we are going to create resources and all those things, but in this one we are doing a lot more connected and complex environments. Okay, for example, we are doing it on Azure, and we are doing a very high level load balancer with availability sets, okay, VNet, subnet, and NSG rules, okay, mapping all those things and everything to Terraform. You don't have to log into Cloud Portal at all, okay, because customers are now going in that way. Customers, and they don't want their team to use Cloud Portal at all. Okay, everything has to be managed through Terraform. So the usage of Cloud Portal will drastically come down in 1 or 2 years. Okay. So we are already seeing that with a lot of customers where teams, they don't even get the access to the portal. Okay, I will tell you why it is happening. Okay, what is the driving reason for it? And again, the similar like I will do one example with the AWS as well. Okay, maybe for one more S3 bucket example, we are going to do some key vault we are going to do. Then we will do the in that containers as well, Kubernetes. Okay, and we'll take Azure App Service Plan, App Service. Okay, all that. So we'll do a lot of examples, and based on the interest of the candidates, we'll go for some examples from Google as well. And we are going to primarily use our Visual Studio Code. Okay. Let me give you some quick 2709. Okay. So what we are going to do is like in whatever topic we are going to learn. So here I'm not going to teach you that, like don't see the content or try to see how you will be taught in the actual day-to-day interaction. Okay, so it will be like 30% theory will be there and 70% your practicals will be there. Okay. So for example, we are going to create some resource in Azure. Okay, in Azure, whoever candidates are there, like students are familiar, they know there is a resource group is there, okay, which is a logical container to create resources further inside that. So we are going to create a resource group. Okay, so for that, again, we know Terraform, everything is a block. So whatever you define, you have to define inside the Terraform block. Okay, and now here we will try to use wherever possible. If we don't have to remember, you can take the help of the IntelliSense. So the Visual Studio has got the IntelliSense built in. Okay, so we are going to have a Azure provider. Okay, Azure RM. So at this point, you don't have to like worry further. So this again, we are going to read in a lot of detail. Sorry. Okay. So here in this, like the Terraform comes into mainly there are mainly two components. One is the Terraform core and one is Terraform provider. Okay, so not going to further detail of those. So what we are going to what we are going here is that we are creating the providers, and it will download when we are doing when we'll execute the commands. It will go to this place, the Terraform registry, and it will go and download it here. The Azure RM, it will download. So now let's say we are going to create a Azure RM underscore resource group. Okay, so this is the name of your variable block. And in this, we know whatever things are mandatory or something we have to declare. So these are all the arguments. Okay, we have so name we have to give. We have to name the resource demo resource 001. Okay, location. Let's take it West Europe. Okay. Okay, so this is our file is done. Let me go to the actual folder. Where is this located? CD 27. Okay. So first command which we are going to do is Terraform init. So there are certain commands are there to do the flow. Okay, and which we are going to read in very deep detail on that. Okay, so at this point, not to worry. So first we are doing a Terraform init. So there are a couple of 3 or 4 commands are there initially, which is needed day in, day out actually. So this is one of that command. So what it does here, it downloads all the provider. It goes to the HashiCorp and it downloads that. I will show you where it downloads it from. Okay. So it goes to the registry Terraform IO, and this one. So currently you see these many, all the vendors are supported by Terraform. Okay, so you can build resources for in AWS, Azure, GCP, Kubernetes, Alibaba Cloud, okay, OCI Cloud, Oracle Cloud, IBM Cloud. Many are there here. Okay, like currently 1,000+ are there. Okay, similarly, when we see there are 7,000 modules. Okay, so you can create and like whatever possible through the portal in Azure or AWS, you can do it from Terraform. Okay. So what it does, it goes there and it will download all the plugin. Okay, whatever needed to create this resource group, whatever is needed, it will go and download. We don't have to worry for that. Okay. And it downloads that in this folder, the .terraform, which we will in the actual class and all we are going to see in depth where what all files are there. So now our code is downloaded, it's validated as well. So now we will do the Terraform plan. Okay. So in this command, it will just tell like what this is going to do. Okay. So it checks all the syntax of this our code and all, and it will tell us like what will be the end state. So here it goes to the actual backend cloud. It will go to the Azure and it will check, is there any similar name cloud is there or not, like that. Oh, sorry, similar name resource group, any chances conflicting name is there or not, all those things, all the checks it will do. So now it is telling me in this plan, 1 to add, 0 to change, 0 to destroy. So yeah, it is telling, okay, this will be added, this resource group will be added. Okay, so I'm fine with this changes. So now I will do the Terraform apply. So in this apply, it will actually go and create the resource group. Okay, we'll validate it once it's done. Yeah, so it is prompting. You can even. So once we confirm that we are fine with that, it's proceeding with the resource group build. So a resource is created and we can see it portal.azure.com. So whatever we created, demo resource 001. Portal, sometime it takes a couple of seconds to catch. Yeah, so this is, you can see demo resource 001. Okay, now I told you that companies are going they're going away from the portal way of working. Okay, so the teams who are working in portal, they will be all like encouraged to work only on the Terraform side. Okay, so wherever companies are going for Terraform, they are sticking to Terraform. I will tell you one of the primary reason for it. So let's say this resource is created. Okay, consider this is some, just assume it is some VM, very critical VM and all that. Okay, and you did some change without the knowledge of Terraform. So for example, in this one, we are just doing a simple tag. We are tagging this to environment, let's say production. We are just doing a tag. So this fine. So we did some changes now, which is out of Terraform. So Terraform has not seen it. Okay, this. So now when we do the again the apply, let me do the auto approve now. Okay. So here it is not going to prompt me again. Usually these all things will be auto approved in the actual your project and all, because they all will be driven through some pipeline or some event based all the. Okay, so nowhere somebody has to press Y and yes and all those. Okay. So once now when you see it saw the thing, whatever is it's telling here, Terraform detected the following changes made outside of Terraform control. Okay, so it is going to enforce our desired state, and the desired state is this. So desired state doesn't have a tags. Okay, so it enforced the desired state. So whatever changes was done, now this environment, let me refresh it. So you can see that change is gone. Okay, so it's a very small minor change which we did, but consider if it is a critical VM with some very very critical application running on that, and some changes were done outside of it. Okay, maybe it's possible some operations team are there at night 2 o'clock, some alert came and they went ahead and they did some changes with the portal. It's quick and easy. Okay, just to do it. And later down the line, some automation pipeline and all, when your pipeline is getting triggered and all, okay, when the provisioning part, so it will go and enforce your desired state, whatever is defined here. So whatever changes was done to fix some problem, that is now gone. Okay, so that's why it leaves the thing very messy if you are managing your infrastructure through Terraform and in backend portal as well. Okay, so that's why the organizations tend to now reduce the dependency on the portal. Okay, everything you have to manage through Terraform only. They are forcing the projects and all. Okay, so that's a very good practice, because at least there will be one source of truth all the time. Okay, or maximum what organizations are doing, like, okay, your team will get only the reader access. Okay, you won't get the contributor or editor access. You won't get the owner level access. You will just get the reader level, just to validate. Okay, validate the things if it got created or not, or anything you have to do. Very minimal access. So this is the direction where organizations are going. Okay, and we see that in multiple organizations. I've seen that they are going in this direction. So it's better to be prepared for in advance. Okay, the thing which will happen in 2 or 3 years, better to be ready from now onwards. Okay, so that's why if you're managing something from Terraform, manage it only from Terraform. Okay, so that there won't be any such issues like this. So this is one of the quick example from Azure side. So our code is not limited to Azure. We can obviously in the same file only we can create AWS as well. We can create some AWS resources, okay, on the GCP resources as well, or you can have separate file as well. Okay, just to show you that it is possible, we will. So here again we are telling we need the AWS provider, and go there and download it. Okay, HashiCorp AWS. So it will, the host name is actually hidden, because by default it is we are going to HashiCorp only. Okay, so that's why the host name is not given. We'll see much detail in the Terraform when we're going to bring the Terraform block in the second section. Okay, so then we need again the provider block for this. Now we are doing the provider block for AWS, and we will take the, let's say, the region US East one. Okay. Let me just quickly check if I have. Let me see if already I have some VM or not in that. Yeah, I don't have anything. Okay, so yeah, we can use US East 1 region. Okay, and now what we are going to do, we will create a small just AWS instance. Okay, And again, whatever variables are there, we can take it from here. Let's AMI, we will get it. It's a quite the Amazon your machine image, and we would need the ID for it. We'll see that in just a moment. And instance type, we will, let's take it T2. We'll take the smallest T2.nano. Okay, the cheapest one. And then let's give some tag. Okay. Or to log into that VM. Before that, let's take the launch instance. We'll take the AMI ID. It's quite a long number. Okay. AMI ID is this. And now what extra we would need is, we would need the key, whatever to log in. Okay. So key pair, let me just see whatever key is there to log into the server. Ranjit. Okay. Key name equal to Ranjit. So this key will be used to log into the VM. Okay. So this is very small, just an example VM, just to see whether our code is running. Okay. Terraform plan. And again, we have to do init now because we are using a new provider, AWS. Okay. So to Terraform, what it does, to keep your software modular, it doesn't download everything at once. Okay. So Terraform can manage a lot of cloud, GCP, Google, DigitalOcean, IBM, everything, but it doesn't mean that whatever code you write immediately it will start managing. Okay, you have to use the specific provider. So here in this case, we are going to create resources in AWS. So it will, yes, it will go and download whatever needed thing only for AWS. Okay, to provision something in AWS, it will download the provider plugins. So we have to do Terraform init. Here you see, here it is finding the latest one, it will do that. So what you do in the actual class, the students, they parallelly do it sometime, and sometime if they can later refer the video as well, and they do it. Okay, so it's, I would prefer, like, if they're doing parallelly, it gives, any issues are there in the same time only, I can solve it there. Okay, so let's go for Terraform plan and Terraform apply after that. So at this point, these are very tiny, small examples are there. Okay. And gradually, slowly, as we go the sections and all, your number of these lines will go in hundreds. Okay, when we are connecting when we are creating many connected resources. Okay, for example, your load balancer, your probe, your backend pool, okay, front-end IP group, and all those things. When we are creating subnet, VNet, and also think how many number of resources you are creating. The plan itself will take minutes. Okay. So Terraform apply. Auto approve I will give, so that it won't prompt me. I know whatever it is creating is fine. So at this point, we're going with a lot of defaults in the in that. Okay, for the disk size and all those encryption and all, everything is configurable. Okay, so let's say you want some OS disk size to be different and all. Okay, so all those things you can do. You can you want the VM to be in a particular AWS zone, you can do that. Okay, all those things are configurable. We are taking a very simple example at this point, just for the sake of time. So during each class, it will be like this. Our sessions will be mainly 30% theory and 70% practical. Okay, in this way we will go. And time to time we will just revisit the certification contents as well, the certification topics as well, so that we will ensure that, okay, those are definitely covered. Okay. So here it is saying our one instance is added. We will go to the portal, to the EC2 dashboard. Now we can see our one instance is running. Okay, server 001 just created our server 001 here. So this is all good. Once we we are happy with that, we usually destroy the things. Destroy. So let me type this. But usually AWS free, it covers within the AWS free tier, but just to save the credits and all, because our main aim is to see our automation pipeline is running or not, all the commands are running, and the provision, the resources getting provision. So once that is fine, we will just delete that, whatever resources we created. So it's quite quick. So for Azure also, if somebody is going for the pay-as-you-go subscription and all, the cost wise it will be very cheap. Okay, so because we hardly we keep the infrastructure just maybe for few minutes, that's it, and we will destroy it. So here in this case, you saw it will maybe less than a minute or something only. It's, the infrastructure was standing. Okay, then we removed it. So cost wise it will be very less, I guess. So I think these all are there, and so this all will be removed from the portal. So I would say that is the demo. Okay, and any specific topic if you want to go, like maybe you are creating a container and all those, we can definitely go a little bit deeper in that. And in our example, we are going to create a Docker container locally, and we will upload that container to the Azure Container Registry. Okay, and then you can use it further to create a Kubernetes cluster and all. Okay, those examples also we will take it. So we will cover a lot of horizontal breadth of examples, ranging from infrastructure as a service, then platform as a service, SQL database will be there in it, and your S3 storage, Azure containers. Okay, then Azure storage container, I meant, and the Docker containers and the Kubernetes. Okay, so all these we will cover in that. So it's quite exciting to learn. Okay. And personally, you don't feel it is quite a complicated and all. It's quite easy to learn. Okay, I would say. And once you do hands-on, it feels more interesting when you see the resources popping up in the cloud. You feel happy that okay, yeah, definitely you wrote few lines of code and you are able to create the resources, and that code will be production ready. Okay, so that code can be reused by any other person. Now you have whatever code you have written, anybody can use it just by giving the variable different, they can do it. Okay, and you don't have to even hard code the variables. You can pass these variables externally, okay, from the command line or anywhere. So yeah, so these all are the demo session. I hope you enjoyed the session. Thank you all.